All right, how many different possible integer values are there for the mean, meaning the average, of a set of three distinct, meaning different, positive integers, the greatest of which is 50. So 50 has to be included. So I'm going to start with the smallest I could possibly get for an integer value for the mean. So 50 has to be used, but the other ones can be really small, so maybe 1 and 2. But if I add those up, I get 53 divided by 3 numbers. That does not go in evenly. Well, what if I tried 51 and 3? That would give me 54. Oh, that does go in evenly. And 54 divided by 3 is 18. And then I could find all the other values. I don't need to do that. Like I know that I can find for 19, because that would be making a sum of 57, and I know I can do it for 20 and so forth, making a sum of 60 divided by 3. So I can make all these other sums, so I don't need to waste time with that. I just need to find out now the largest. So what's the largest I can use if 50 is my highest number? Well, I could have a 49 and a 48. And since 49 is smack dab in the middle of those two, I know that mean is going to be a 49. So it's really starting with 18 all the way up to 49 is my range of values. And I'm including the 18, so the shortcut here is just do 49 minus 18 and get 31. And I'm going to add 1 since I'm including that first number. So there are 32 values. Okay, number 6. Right triangle ABC has integer side lengths. That means they all come out as whole numbers here. The altitude, that's this thing right here making that right angle. The altitude from the right angle at C intersects AB at point D, and the length of CD is 12. So I'm going to put a 12 there. And then if the side lengths of CAD and BCD are also integers, what's the minimum perimeter of ABC? So all the way around this triangle, what's the minimum perimeter? All right, well, I know that this problem is going to have some Pythagorean triples in it. And my most basic ones, of course, are 3, 4, 5, and the 5, 12, 13. So I'm going to just see if either of those are going to be used here. And it does say minimum, so I want to try to use the smallest possible. So let's say if it was the 3, 4, 5, that 12 right here is a leg. So that's either this one or this one. Why don't I put that one on there to minimize it? Why don't I make that 12 here? So if I multiply that by 3, it would be 12. If I multiply this one by 3, it would be 9. Multiply this one by 3, it would be 15. And that'll minimize this. So 9 and 15. If I did it the other way, just to show you guys, if I put the 12 there, it would have been times 4 times 4 times 4, and that would have given me bigger numbers, right? So it said minimum perimeter, so I'm trying to make those as small as possible. All right, so now for the other picture, I can tell just by the picture that this side is going to be smaller than this side. So maybe the one I just used actually will work for that. So if that's a 12, that's a 16, that would make this a 20. And then it looks like I just need to make sure that this actually comes out right if I do Pythagorean theorem. So 20 squared plus 15 squared, and I do have a calculator. I need to make sure that that equals 25 squared. So 400, actually I don't need a calculator for this. 225 adds up to 625, and I actually know the shortcut with 25 squared is 2 times 3, which is 6, and then it ends in a 25, so 625. It works. That's awesome. So now I just need the minimum perimeter of ABC, so I just add up this, this, and this, which gives me, 35 and 25 adds up to 60.